Good morning. This is your Stat Sensei, Mr. Spensei, and this is a chi-squared test that we're going to run, and it's going to be on the I'm a loser baby scenario. And this is the same one we looked at or one of the ones we looked at in the warm-up. So, I'm a loser baby. A nonprofit organization, Hope for Hungry Children, is hosting a charity fundraising event to support families struggling with food insecurity. As part of the event, they introduce a fundraising prize wheel where participants pay $40 per spin to win cash prizes that range from $0 to $100. The wheel is divided into 5 equal sizes. All right. It's going to be important with equally likely outcomes. Several donors landed on zero because you could win $0, $10, 25, 50, or 100. But several landed on zero and began to question whether the wheel is fair. Worried that trust in the fundraiser might be compromised, the organization investigated and collected data from 150 randomly selected spins. So we have a sample size of 150. We know that's going to be important. We'll go ahead and make a note of that. On an evening when it was spun 12,875 times, so we have a population size of 12,875. All right. So we just copied that information, by the way, down onto our table here, 0, 10, 25, 50, and 100. All right. So we just copied that information down. And it says, based on these data, can you conclude the wheel is unfair at an alpha of 5%? So basically, we have alpha equal 0.05. Now, one thing they told us is, and by the way, let's go ahead and do this real quickly. We went ahead and put this information in the stat edit. We did this in the warm-up as well. And we go stat calc, one var stat, and we look and go, oh, that does sum up these values, these numbers, the number of spins, the 55, the 30, the 28, the 22, the 15 sum up to a total of 150 spins. We also know that the probability of all probabilities sum up to 1. In this case, it's 1 out of 5 chance. So basically, we know that we can go 1 divided by 5, and the probability of winning any one is 0.2. So let's go back to stat edit and go 1 divided by 5 and get 0.2, and we just can copy 0.2 all the way down. Now, that's not our expected value. That's the chance we have of winning. There's a 20% chance we'd get $0, a 20% chance of $10, 20% chance of 50, and a 20% chance of 100. So I'm going to go ahead and add that up there just as a reminder to us that we didn't forget about it. The 0.20, this is also 0.20, 0.20, 0.20, and 0.20. And if we add up those 20 and 20 is 40, plus 20 more is 60, plus 20 more is 80, plus 20, that's one whole. All right. So the probability of winning any one of those is 20%. But we need to know the probability, we need to know the expected value. Well, expected value is the sample size times P. Well, our sample size is 150, and we know our probability is 20. So we're basically going to go 150 times 0.2. So to do that, I'm just going to go blue 2 times 150. And I end up going, hey, my expected values of 30. And now I kind of have everything from my formula. My formula is observed minus expected squared over expected plus observed minus expected squared over expected. Well, we have our observed values. So that's the 55 who got $0 out of the expected 30. All right. So at this point, I can go ahead and plug into my formula. All right. And when I plug into my formula, I have a little trouble there. It's going to be my observed, my first one, which is 55, observed minus expected over my expected. 55 minus 30 squared over expected. Plus dot, 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 plus. Then we go to the last one. Observed of 15 minus expected of 30 over expected. Degrees of freedom. It's levels minus 1 or categories minus 1. So in this case, we have 1, 2, 3, 4, 5. So 5 minus 1, our degrees of freedom is 4. At this point, we have all this information in the calculator. We can go ahead and run this test. So stat test chi-squared, and it's a goodness of fit because it's only one variable, L1, L2. Degrees of freedom are 5 minus 1 or 4. And we end up getting x squared, 30.6, and a p-value that's really, really small. Our p-value right here says, hey, you know what? This is a -6. That means there's at least 4 zeros. So our p-value is approximately 0. All right? So our p-value is approximately 0. And remember, our chi-squared is always going to be, every single time, skewed to the right, and it'll start to 0 and go to positive infinity. All right, we're running a chi-squared goodness of fit test. All right, and we need to write our hypothesis. All our hypotheses start off the same way. Each of the sections on the spinner have the same frequency of being landed on, or same probability. Each and same are the key words, all right? And if you want to say they had to each had the same chance of being each of the spinner had the same chance, or each has the same probability, that's fine. We use the fancy word frequency, and that's fine as well. Then the alternative, also super important. At least one of the sections of the spinner does not have the same. And I'm just going to tell you, not have the same is going to show up each time. Otherwise, the sentences are exactly the same. So please note, the null each has the same, does not have the same. At least one does not have the same. Okay, those are going to show up every single time we do one of these chi-squared tests of goodness of fit. All right, conditions. First condition is the randomization. Is it? Yes, they told us random sample, randomly selected of 150. That was given. We need to make sure our sample size is not too big, and we go 150 times 10, and 10 is 1,500, and that's less than our population size of 12,875. So N is less than 10% of the population. All right. The next thing we need to check is to make sure our sample size is big enough. Well, that means all expected values have to be greater than 5. Let's see the table above. Well, we already calculated them, and our expected values in this case, every single one of them, were 30. All right. So all of our expected values were 30, which is greater than or equal to 5. So that takes care of that. Well, we ran the test, and we can go, well, the probability of a chi-squared being greater than 30.6 is approximately 0. Well, that's less than our alpha. With that, we'll have a decision of reject and null. So our p-value is 0, which is less than our alpha 0.05. We reject the null. There is plenty of evidence there to suggest at least one, and by the way, we should be noticing something. At least one of the sections of the spinner does not have the same frequency as being landed on. This last whole sentence, beginning at least, just like every other time when we've done one of these, every time we've written a hypothesis test, we always restate the alternative hypothesis, right? Every single time. So that's our HA, the restatement of the alternative hypothesis. I hope this helps. I look forward to seeing you on the next one. Thank you.